Okay, so today we're working on a Fender Blues Jr. guitar amplifier, and a buddy of mine said it doesn't make any sound and it needs to be fixed so you can start playing it again. Now I've already tested it out because that's the first thing you do. You plug in your guitar and you confirm the problem that was described by the person that asked you to work on something, and sure enough, it does not make any sound. So I started by taking all the knobs off of the guitar amplifier and undoing the nut that was there, and then undoing the nut on the input jack, and then taking all the screws out of this back plate here, and this comes off, and then there's our circuit board, and you can see the tubes down here. Got your preamp tubes on the right and your power tubes on the left there, and then there's your speaker, and then let's see, this is where the power comes in from the wall, and that goes into the transformer through the switch on into the power section of the circuit through the fuse, and then one of the things I noticed as I was poking around in here is if I touched, I bumped this capacitor, and when I did, it's really wiggly, which tells me that there may be a problem with the trace on that side connecting that capacitor to the rest of the circuit. So I'm going to definitely take a look at that. We're also definitely going to take a look at the solder connections on the input jack here. I've actually gone ahead and removed these screws from all these points that were holding the circuit board in place. Alright, so I got this circuit board out of the way, and then that allowed me to push this main circuit board down to get these knobs out of these holes. You gotta be careful because sometimes you can snap these shafts off of these potentiometers. And so now I can actually look at the solder connections on the bottom of the circuit board. So we talked about that big capacitor a moment ago in the power section there, and here's the solder connections for that. Let's see if I can focus. For that capacitor. Now if I push on the capacitor and I look, you can see that might be a problem. So that needs to be resoldered. It looks like the pad on the circuit board has just come off completely. So what I'll do, I have a couple of different options here. One, I could take like a sharp knife and I could scrape off some of this green insulation over these copper traces here, and I could just solder the leg of that capacitor directly to the trace and reconnect it that way. Or I could cut a piece of jumper wire and then solder the piece of jumper wire from there to another solder connection that it's supposed to be connected to based on where I see these traces going. Now this solder joint on the left here is kind of at an intersection, so I'm going to have to make sure that, you know, if I used a jumper wire and I just soldered from there to maybe one of these two, that's reestablishing that one connection, but I also have to make sure I have this connection going over here and then this connection going over here as well. So I gotta make sure it connects to all three of those. Other than that, this I've noticed this right here, which is kind of ugly. That looks like someone tried to add that potentiometer right there, that blue box with the screw in it, that itty bitty flathead screw. That is a variable resistor, multi-turn sort of trim pot, trim potentiometer. That got replaced or added in or something, but it does not look like it is original to the unit. But I don't know. I can't. It looks ugly, but is it not working? That's the question. It looks like it goes over to this trace here, and then that, I don't know if that's actually this solder connection, that big blob there. I don't know if that's actually connected to the other two pads on that little trace there. I'll have to check that with a digital multimeter. I'll go ahead and do that now, actually. Let me get my digital multimeter, set it to continuity, and then make sure it's working by touching the ends of the probes together. Okay, that works. I don't know how I'm going to do this with only two hands, but I'm going to try. Alright. If this blob is actually connected on that trace. Okay, it is. I think it's okay. I think that's actually making a connection. So as ugly as that looks, I think that's okay. Now, I suspect that what's happened is this person, the owner of this guitar amp, found a mod online, which is a short for modification. It's where you go in and I'm gonna, replace this part with that part, or I'm gonna add a potentiometer or something like that. Mods are kind of, people who are electronics enthusiasts will come up with mods to do and then publish them online, and then people will go and do that. Some mods, especially if it's a mod that's sort of put together by someone who's not an electrical engineer, can have unintended consequences and cause electronics to do things that they're not supposed to do. But other times mods can be pretty harmless and maybe beneficial. Generally, I avoid mods, but just make sure you do your research real thoroughly before you attempt a mod, and make sure you're real good at soldering too. Let's see. Okay, and then over here on the input jack, that's where the guitar cable goes in. We see that this looks fine, and this looks fine, and this looks fine, but right here, somebody's used, I think, kind of a crude soldering iron, and they've managed to burn the pad right off the circuit board. So that leg there, which is the furthest leg in, which makes me think that this is part of the tip connection, which is where your audio is, that's now disconnected from this trace that goes this way. So that's probably why we're not getting audio into our circuit. Okay, I'm gonna resolder some of these things, and we'll see if that fixes it. Okay, so here's a really good example that I wanted to show you guys of what can happen to some of the solder joints on components like controls that you like, push buttons, or these potentiometers, or input jacks, or any of the solder points that get kind of pushed on. When you grab hold of the knob and you make adjustments or whatever, you're actually flexing the legs of that component on the circuit board and flexing the solder joint as well, just a little bit. But over time, you can get, and it's kind of difficult to see, but you can get these little fractures. Like I've got a little fracture on the solder joint right there. And right now I don't think that's a problem for this particular solder joint, but over time that can completely break away and cause just a hairline fracture that's enough to disconnect that electrically from the circuit board. That particular solder joint doesn't matter all that much because I don't think that's part of the circuit. I think that's just to help physically hold that part in place. But that can happen on input and output jacks and control connections. Alright, just going to show you what I did to repair the input jack connection. I took a piece of jumper wire and soldered one end to the end of this trace here. And then I noticed that this solder point and that solder point were both on a trace together at 1.2. So I went ahead and stripped off like a ½ inch of wire on this, and I soldered that there to that piece of wire, and I soldered this one to there on that same piece of wire. So those are all connected like they were intended to be on this one trace. But just as preventative maintenance, I've resoldered all the connections on these pots and input jacks. And then over here, where we have that large capacitor, I think this is a replacement capacitor, because the hot glue that normally holds it in place was kind of gone. And so I got a hot glue gun and I glued it down just to give it some support. And then on the other side, I found that this large trace that goes these three different directions actually was connecting all of those solder points that are on those traces without this, even though that leg was sticking up off the trace itself. So what I did was I started with one wire, but I was a little bit worried, since this is part of the power circuit, that maybe one of those little jumper wires isn't enough metal for the current and the voltage that's involved in this circuit. And I noticed that the trace is extra large here as well. So I went ahead and, this may have been unnecessary, but I put two wires together to double my gauge, since I don't have a thicker jumper wire, and soldered it to the leg of that capacitor and then to these two legs of these components on that same trace, so that reestablishes that connection from the power capacitor. Okay, I've mostly reassembled this. I haven't bothered to put the knobs back on yet because I want to test it before I completely reassemble it. I've got my cheapo, poorly tuned guitar here for testing purposes, and that's plugged into the input of our amp here, and I've turned the master all the way down and the reverb all the way down, and everything else is at noon. Now, it is plugged into the wall, so I'm going to have to be extra careful not to touch any of those connections, because that's got 120 volts on them. And flip it on, and hopefully it doesn't explode. Okay. You can see the tubes warming up. That's good. I think it's okay so far. Okay, let's give the volume a little turn. Oh. That sounds terrible. I should really tune that guitar. But it seems to work. Alright, I will button this up and call it done and give my client the good news.